So there are two main branches of calculus, derivatives and integrals. And so far in this course, we've been studying derivatives, and that's most of what Calc 1 is about. Although now we are entering the second part of calculus, which is integral calculus. So we're going to get an introduction to integral calculus this week, and for the rest of the semester, when we start learning about chapter 5, we're going to be going full bore into integral calculus. So you can think of integral calculus originally or initially as the opposite of derivatives. So if we have some function, like this x cubed plus cosine x plus 2, we can find the derivative, which is 3x squared minus sine x. We can also imagine going backwards. So if we started with the derivative 3x squared minus sine x, we could go backwards to the original function somehow and get x cubed plus cosine x plus 2. That's called an antiderivative. Remember that f, the function, measures a quantity of something, and the derivative measures the rate of change of that quantity. So we have this idea about going from the quantity to the rate, but antiderivatives will go from the rate to the quantity, right? So it's kind of a reverse process there, right? So that's kind of the big idea. Now, if you have an original function that's measured in, let's say, meters, then going to the derivative might find something like meters per second, like a rate, like a velocity. But there's no reason why we just have to think of distance and velocity. For example, suppose a business knew how many dollars per day that they were taking in revenue. Well, going backwards, they could use an antiderivative to find out the total amount of dollars that they're earning. Or suppose you knew something about the size of something and how it changes. That might be measured in area. Area is square feet, maybe square feet per minute. So if you knew something about how an area was changing, you can go backwards to find the total area, which is in this case measured in square feet. So the idea of this antiderivative is we're starting with a rate and we're recovering a total amount of quantity over a certain period of time. That's the idea of an antiderivative. Okay, so sticking points. Well, the sticking points for integral calculus kind of align with some of the misconceptions of mathematics in general. A lot of people kind of think of mathematics as a set of rules or a set of procedures in order to get an answer to a particular kind of question. And certainly there are a lot of formulas and rules, but that is only going to get you so far in math. There's a lot of math which just doesn't fall into any of those categories. And no matter how many rules you know and how many procedures you've memorized, it just won't solve the more sophisticated problems. You really have to be able to have some creative thinking, some working backwards, trial and error, problem solving. And this is kind of what's required in integral calculus. Initially, in finding some antiderivatives, it's not going to be enough to try to memorize formulas. There are literally hundreds and hundreds of antiderivative formulas, not an exaggeration. And even if you memorize them all, it would not be enough to do antiderivative problems, all of them in general. So it has to be methods and ideas that you're learning and not just formulas and rules. So that can be difficult for students who are really in the mindset of, well, tell me the formula and I'll do it. It just doesn't work that way anymore. There are no surprises in terms of what to expect this week. We have web assigned homework. We have a lab assignment. There's a discussion on Canvas. There's a weekly quiz on Canvas. I'm available for tutoring, etc. Please reach out if you have any questions or if I can help you with anything. And I hope you have a very enjoyable week.